In the last video, we used a two-way ANOVA to test the following data about graduates' earnings 5 years after leaving university, given their course and gender. We stated the following three hypotheses. For the first hypothesis, which involved gender, no further testing was required as results were extremely insignificant. For the second hypothesis, we found highly significant results, and to follow up, we want to estimate the effect size either by using a contrast or Tukey-Kramer. As we are interested in the pairwise comparisons of means, we will use Tukey-Kramer. The following R code carries out a Tukey-Kramer test. When I run the command, the results can be seen here. The table gives 6 different effect sizes along with their p-value. Each row corresponds to a different pairwise comparison. The first 3 rows all have p-values below the 0.05 significance level. As a result, we can conclude sports science and geography have significant differences in earnings, maths and geography have significant difference in earnings, and engineering and geography have significant difference in earnings. Furthermore, we can look at the 95% confidence intervals for each pairwise comparison. For sports science and geography, the 95% confidence interval is between 226 and 9,888 pounds. An effect size of 226 pounds isn't very much in the context of what we are dealing with. However, an effect size of nearly 10,000 is quite substantial. For engineering and geography, the 95% confidence interval is between £7,791 and £17,454. Both of these figures are substantial. The fourth row gives a p-value of 0.31, which means there is no significant difference in earnings between graduates who took maths and graduates who took sports science. This is backed up by the fact that 0 lies within the 95% confidence interval. The fifth row shows a significant difference in earnings between engineering and sports science, with a 95% confidence interval from £2,734 to £12,396. £2,734 is a mid-sized effect. A difference of earnings of this size isn't substantial, but it is large enough for us to take note of it. The final row shows there is no significant difference in mean earnings between mathematicians and engineers, with a p-value of 0.09. This completes the follow-up testing for our second hypothesis. We now look at our third hypothesis shown here. In the previous video, this gave us non-significant results. For our follow-up test, we will make a power calculation which will help us to determine the probability we have made a type 2 error. Recall that 1 minus the power of a test gives us a probability we have made a type 2 error, that is, failing to reject the null hypothesis when it is false. To calculate the power, we use the Rust length power applet, which can be found by typing Rust length into Google. I choose balanced ANOVA because there are the same number of people in each cell of our design matrix, and I then choose two-way ANOVA. I keep the rows as 2 and change the columns to 4. So the rows correspond to the 2 genders and the columns correspond to the 4 courses. We have 20 subjects in each of our blocks, so we can change 20 in here. We want to study the power of differences and contrast, so we click here. Due to the size of the numbers that this applet can handle, I will work in thousands of pounds rather than pounds, so 33,000 is now represented as 33. We found our standard deviation to be 8.3. This is the square root of the mean squared error within groups from our ANOVA table. Remember here that 8.3 actually represents £8,300. We are studying our interaction term, so we change this option here to row star column. Suppose we want to detect a difference in earnings of at least £5,000, so we set our detectable contrast here to 5. We can see this gives a very low power of 0.1259, meaning we have an 87% chance of making a type 2 error. The question we should now be asking ourselves is how many people would we need in our sample in a follow-up study to have a power of 0.8? We can find the answer to this by adjusting the n bar here. As I increase n, the power of this test goes up. If we keep going, we eventually gain a power of 0.8. In fact, 84 people in each block gives a power of 0.8, meaning we would only have a 20% chance of making a type 2 error. A more powerful study like this would also allow us to shrink the 95% confident intervals to determine more precisely the difference in average salaries, for instance, between sports science and geography. To summarise, we were given a set of data on graduates' earnings 5 years after university, and our aim was to see if course taken and gender affected the amount earned. We found gender had no significant effect. We then went on to find that different courses did give significant differences in earnings. Follow-up tests allowed us to estimate what these differences were. Finally, we explored the interaction between course and gender and found there was no significant interaction. However, after carrying out a power test, we found our test had a very low power, and hence it was very likely we could have missed an effect as small as £5,000. To get a better understanding of interaction, we found that at least 84 people were needed in our sample. This concludes a set of videos on the two-way ANOVA.